The outer cortex of the kidney has circular bodies that are much larger than all these small tubules nearby, and they're obviously very different from them. These circular bodies are renal corpuscles, and their internal masses are tufts of capillaries called the glomerulus. Look at this outer wall which lines the empty space surrounding the tuft of capillaries in the renal corpuscle. It's formed of extremely flattened epithelial cells as an excellent example of simple squamous epithelium. Both the cells and their nuclei have approximately the shape of pancakes, and their appearance depends to a large extent upon the angle at which you view them. When cut along their length, cells of this epithelium are visible as a very thin layer, and the nuclei appear to be very elongated and dark. Think of how the yolk of a fried egg would look in cross-section. Like most types of epithelia you're going to view, the shape of the nucleus mirrors the geometry of the cell. Let's stick with the section of the kidney. The kidney is made up entirely of long epithelial tubules running in various directions, and so cut randomly in any histological section. All of these epithelia are simple. That means they only are one cell layer thick. Most of the epithelial cells are cuboidal in shape. Look at these cells here and note their rounded nuclei. They form these long tubules. Occasionally you'll notice, such as here and over here, that some epithelia are halfway between squamous and cuboidal, and so they can be called either tall squamous or perhaps low cuboidal. This image lets you further familiarize yourself with the effects of planes of section. Long tubules obviously will look different when sectioned crosswise and longitudinally. In some parts of the kidney, most notably in the medulla, you can see here that the tubules are almost mostly straight with the same alignment and cut longitudinally. This orientation is simple to understand. In other places, I'll show you an image in a moment, you'll find the tubules are twisted all around, like a plate of limp spaghetti that has just been cooked. Now look at this image from an area where all the tubules are circular and so cut in cross-section. Here, all the tubules must be straight and running in the same direction. So if the sections of all the tubules are similarly shaped, the tubules again must be straight and running in parallel. Where the tubules are convoluted, like a limp, cooked piece of spaghetti, their sections take on all shapes. Their section profiles may appear circular or almost longitudinal. And look here at the lumen of this long irregular profile. So the profiles will appear in many shapes.